All right, our next witness is Dr. Carl Sagan of Cornell University, a man who needs no introduction. He comes to us today from the Center for Radio Physics and Space Sciences. We welcome you, and we're very pleased that you would take the time out of your schedule to come to a place like Washington, where everything seems to be living in today and not in tomorrow, to share with us your particular view of how our past and our present may well affect our future. Carl, thank you very much.
Thanks very much, Senator Durenberger, Senator Gore, Senator Burdick. I'm glad to be here. As I understand my function, it is to give some sense of what the greenhouse effect is, to try to say something about greenhouse effect on other planets, to again underscore that this is a real phenomenon, and then perhaps I can take liberty to say a few remarks about what to do about it. The power of human beings to affect and control and change the environment is growing as our technology grows. And at present time, we clearly have reached the stage where we are capable, both intentionally and inadvertently, to make significant changes in the global climate and in the global ecosystem. And we've probably been doing, on a smaller scale, things like that for a very long period of time. For example, slash and burn agriculture, which has been with us for tens of thousands of years probably, changes the climate to some extent by changing the albedo, the reflectivity of the Earth. That massive changes have occurred is clear from the historical record. For example, Egypt was once the breadbasket of the Roman Empire. It may be the same role as the American Midwest plays today. That is certainly no longer the case. It's not a greenhouse effect issue. It may be an overgrazing issue, but is an example of how humans are perfectly capable of making these unexpected and inadvertent changes. Because the effects occupy more than a human generation, there is a tendency to say that they are not our problem. Of course, then they are nobody's problem. Not on my tour of duty, not on my term of office. It's something for the next century. Let the next century worry about it. But the problem is that there are effects, and the greenhouse effect is one of them, which have long time constants. If you don't worry about it now, it's too late later on. And so in this issue, as in so many other issues, we are passing on extremely grave problems for our children when the time to solve the problems, if they can be solved at all, is now. If you ask what determines the Earth's climate, clearly the main thing that determines it is sunlight. Sunlight is what heats the Earth. Not all the light that arrives at the Earth from the sun goes to heating the Earth. Some of it is reflected back. It's just the part that is absorbed. And what happens is there's a certain rate at which sunlight is absorbed by the Earth's surface, and there's a certain rate at which the Earth's surface radiates to space. What comes from the sun is in the ordinary visible part of the spectrum that our eyes are sensitive to. What the Earth radiates into space is in the infrared part of the spectrum, longer waves than red, that our eyes are not sensitive to, but it's as legitimate, excuse me, a form of light as the kind that we're used to. Now, if you calculate what the temperature of the Earth ought to be from how much sunlight is being absorbed, equaling how much infrared radiation would be radiated to space, you find that the Earth's temperature, by this simple calculation, is too low. It's about 30 centigrade degrees too low. And why is it too low? It's too low because something was left out of the calculation. What was left out of the calculation? The greenhouse effect. The air between us is transparent, except in Los Angeles and places of that sort, in the ordinary visible part of the spectrum. We can see each other. But if our eyes were sensitive at, say, 15 microns in the infrared, we could not see each other. The air would be black between us, and that's because, in this case, carbon dioxide. Carbon dioxide is very strongly absorbing at 15 microns and other wavelengths in the infrared. Likewise, there are parts of the infrared spectrum where water vapor absorbs, where we could not see each other if we were only as far apart as we are in this room. If you add these infrared absorbing gases to a planet, then what happens is the sunlight comes in as before, but when the surface tries to radiate to space in the infrared, it is blocked, it is impeded by the absorbing gases. And so the surface temperature has to rise so that there is an equilibrium between what comes in and what goes out. So this is the greenhouse effect. It is a misnomer for more reasons than one. It's a misnomer in particular because that's not how the florist greenhouse works, but that's a very minor point. There are other gases which absorb in the infrared, many of which have been mentioned already: nitrous oxide, methane, the halocarbons, and these are products partly of agriculture. It's fertilizers, refrigeration, aerosol spray cans, and so on, all products of our technology. We don't generate much water into the atmosphere, but we certainly do generate a great deal of carbon dioxide through the burning of wood and fossil fuels, an apparently benign activity. Who could object to humans burning oil and coal, gas, and wood? I'd like to stress that the greenhouse effect makes life on Earth possible. If there were not a greenhouse effect, the temperature would, as I say, be 30 centigrade degrees or so colder, and that's well below the freezing point of water everywhere on the planet. The oceans would be solid after a while. A little greenhouse effect is a good thing. But there is a delicate balance of these invisible gases, and too much or too little greenhouse effect can mean too high or too low a temperature. And here we are pouring enormous quantities of CO2 and these other gases into the atmosphere every year with hardly any concern about its long-term and global consequences. Now, certainly not all aspects of how increased CO2 and other gases into the atmosphere affect the climate are known. There are still many uncertainties, although the overall picture is, I think, quite clear and quite widely understood and accepted. But there are questions about aerosols, about clouds. You heat up the Earth. How much increase or decrease in cloudiness is there? How does that change the albedo or reflectivity of the Earth? There's questions about the ocean and its response time to an increase in CO2. There are feedback effects. And therefore, it is certainly worthwhile to spend some additional money on further research on the subject. Another point is that the significant temperature changes on the Earth between ice ages and out of ice ages, glacial and interglacial time periods, seems to be connected with quite small changes in the amount of sunlight that reaches the Earth due to changes in the Earth's orbital properties. And that is a suggestion that the Earth's climate system may be very delicately dependent on the sorts of factors that we're talking about here. And that's why it makes sense to study past climatic change on the Earth as an attempt to obtain some calibration. Another source of calibration is the other planets. Every planet with an atmosphere has some degree of a greenhouse effect. The most spectacular case by far is the greenhouse effect of Venus. It's the nearest planet. It's a planet about the same mass, radius, density as the Earth, but it is spectacularly different in several respects, one of which is that the surface temperature is about 470 degrees centigrade, 900 Fahrenheit, and that enormous temperature is not due to its being closer to the sun, because Venus is surrounded with bright clouds, and in fact, because it reflects so much light back to space, if that's all that was happening, it would be cooler, not warmer, than the Earth. The reason for this absurdly high temperature on the surface of Venus which is well understood. I mean, Soviet spacecraft have landed on Venus and, in effect, stuck out a thermometer. There's no doubt that surface temperature is very high, and later U.S. spacecraft have as well. The reason is a massive greenhouse effect in which carbon dioxide plays the major role. Now, the amount of CO2 in the Venus atmosphere is much larger than here. The atmosphere is almost entirely carbon dioxide, and there's 90 times more of it there than here. But it is an indication of what can happen in an extreme case. You look at Mars or Jupiter or Titan, the big moon of Saturn, and you have additional examples of greenhouse effects, different gases, different amounts of sunlight reaching the surface, different planetary albedos and cloudiness, and in all those cases there is also a greenhouse effect. In addition, it has been possible to calculate those greenhouse effects fairly accurately, so that the kind of theoretical armamentarium which is used to calculate the greenhouse effect changes on the Earth, is also used for other planets and therefore can be calibrated to some extent against those other planets. If we keep coming out with the right answer in all those different cases, then probably we understand fairly well how greenhouse effects work. It would, however, be worthwhile, along the lines that Senator Gore was talking about, to have an increased program through NASA to understand the greenhouse effects on other planets. This might be a very practical application of planetary exploration. As you've heard, the best estimates, they certainly have some uncertainty attached to them, are that at the present rate of burning of fossil fuels, the present rate of increase of minor infrared absorbing gases in the Earth's atmosphere, that there will be a several centigrade degree temperature increase on the Earth, global average, by the middle to the end of the next century, and that has a variety of consequences, including redistribution of local climates, and through the melting of glaciers, an increase in global sea level. There is concern on a somewhat longer time scale about the collapse of the West Antarctic ice sheet, and a general rise of many, many meters in sea level. So we have a kind of handwriting on the wall. Certainly there's more research to be done, but as I say, there is a consensus. What can be done about it? The idea that we should immediately stop burning fossil fuel has such severe economic consequences that no one, of course, will take it seriously. But there are many other things that can be done. One has to do with subsidies for fossil fuels. More efficient use could be encouraged by fewer government subsidies. Secondly, there are alternative energy sources, some of which are useful, at least locally. Solar power is certainly one that might be of more general use. Safe fission power plants, which are in principle possible. And then on a longer time scale, the prospect of fusion power. Fission and fusion power plants, in principle, vent no infrared active gases, and therefore, whatever other problems they may provide, they do not provide a greenhouse problem. I'd like to close by just saying a few words on the kind of perspective that this problem, as related problems, pose to us. Here is a problem which transcends our particular generation. It is an intergenerational problem. If we don't do the right thing now, there are very serious problems that our children and grandchildren will have to face. It is also a global problem. It is no good if just one or two major industrial nations take major steps to prevent a major increase still further in CO2 and other greenhouse gases, because other nations may, through their industrial development, cause the problem by themselves. And not to say that this is inevitable, but just to give an example. The largest coal reserves on the planet are the United States, the Soviet Union, and China. China is undergoing a very major industrial development, and the burning of coal is certainly something that must be very attractive for the Chinese looking into the future. I would say that there is no way to solve this problem, even if the United States and the Soviet Union were to come to a perfectly good accord on this issue without involving China and many other nations that will be developing rapidly in the time period we're talking about. So here is a sense in which the nations, to deal with this problem, have to make a change from their traditional concern about themselves and not about the planet and the species, a change from the traditional short-term objectives to longer-term objectives. And we have to bear in mind that in problems like this, the initial stages of global temperature increase, one region of the planet might benefit while another region of the planet suffers. And there has to be a kind of trading off of benefits and suffering, and that requires a degree of international amity which certainly doesn't exist today. I think that what is essential for this problem is a global consciousness, a view that transcends our exclusive identifications with the generational and political groupings into which by accident we have been born. The solution to these problems requires a perspective that embraces the planet and the future, because we are all in this greenhouse together. Thank you, Mr. Chairman.
Well, thank you very much. Just a frustration on international amity. Some of us made a brief trip in August through Sweden, Switzerland, Germany, and then I went into Poland, and concerned about what we call acid rain and some of those consequences. And as I went, the urge in me for some forum for international amity, it kept crying out, particularly when I got to Poland, which is the home place of my mother's side of my family, and to see the self-destructiveness of that economy and on the people of that country, and the lack of amity on the part of the Czechs, and on the part of the East Germans. It's just a frustrating experience. All of you must experience it every day of your lives, and I hope there is an answer in something other than legislation. But it is your concerns and those of many of us, people who are familiar with some parts of this problem and related problems, I guess have to somehow take this place beyond an amendment to require the United States contribution to the United Nations to be no greater than the contribution of the Soviet Union, and to somehow lift the people that claim a right to a place in the United States Senate beyond that kind of a view of the world, and lift it up somewhere closer to the real issues that affect people. And I had to say that. I was listening to your comments. Let me ask you, and I intend to ask the other witnesses this, and that is whether the following is an accurate summary of the current state of our knowledge on this subject. Now, for the first time, there is international scientific consensus that global warming can and will occur. While there's still uncertainty surrounding these predictions, it runs in both directions. That is, while global warming could be less than expected, it is at least as likely that it will be much worse. Third, all predictions are based on the assumption that a new man-made atmosphere will behave in the same way that natural atmospheres have in the past. Fourth, global warming, much like fever in a human being, is serious in itself, but is also a symptom of massive perturbation of the natural, physical, and chemical processes. And fifth, relatively painless actions can be taken which would slow the warming trend. For example, the use of CFCs and spray cans could be banned throughout the world. maybe. Cars and trucks could be required to meet stringent carbon monoxide standards, such as those in the United States. Again, maybe, depending on our international amity. And forests can be reseeded. Is that a fairly accurate summary of the current state of our knowledge?
The only statement in there that I would have some quibble with is the one which goes that scientists are assuming that the atmosphere with the increased infrared absorbing gases in it will act the same as the present atmosphere. I don't believe there's any such assumption. There are calculations from first principles, but apart from that, what you read seems.
Yeah. You were invited to testify because you're something of a scientific generalist, and one of your best qualities is the ability to explain complex scientific issues in a way the layman can understand, and you have also worked on a variety of these issues. One scientist who works in this field was recently asked why he was devoting so much time and attention to it when there seemed to be more urgent problems, and his response was that in his judgment, climate alteration was the most serious threat to humanity and global peace short of nuclear war. Those seem like strong words even from a person who's committed his entire life to the problem. You are more of a generalist than the person I'm quoting, and you have spent time considering the implications of other threats, including nuclear winter, in the context of potentially cataclysmic events. How would you score climate alteration?
I recognize the need for a rank order of catastrophes, so we know which one to devote our attention to first. But I would hope that we could concentrate on several potential catastrophes at the same time.
Which two or three?
I certainly agree with your anonymous informant that nuclear war is far and away, heads and shoulders, the most dangerous threat to the nation and the world and possibly the human species. I also agree that the sorts of climatic effects that we're talking about today are very serious because they have global purview and because they are so intimately tied to something which we are so reluctant to give up for clear economic and other reasons, namely the burning of fossil fuels. In 1945, after the first nuclear explosions, Einstein said that everything had changed except our way of thinking, a remark that certainly is still applicable today, and I think is applicable to this particular issue. And that's what I was trying to stress in my testimony, that there is a kind of global and intergenerational thinking that is essential for dealing with these problems, the nuclear war issue as well, and other candidate catastrophes like AIDS and other new epidemic diseases, all of which cannot be resolved except on an international global basis. The eradication of smallpox, for example, to take a successful example, was done at the expenditure of a few tens of millions of dollars by a planetary effort by the medical community, and is an example of a problem that certainly was considered very difficult some 1,000 years ago, that is now it's completely gone. There are no more cases of smallpox on the planet. So it's a reminder to us that these problems can be solved, but not if we persist in keeping to our narrow frames of interest in space and in time.
Thank you. Mac?
Yeah. Dr. Sagan, a lot has been written about, a lot of people have spoken about some of the adverse effects of increased carbon dioxide and other gases. Are there any benefits? That is, one can argue that in some of the colder climates of our country, warmer temperatures would help.
Well, having just come from upstate New York, I know what you mean, Senator Baucus. the distinguished scientists who will follow me on this panel would be better qualified than I to answer that question, but it is clear that increased carbon dioxide for many plant species produces a more luxuriant growth. That's true both of crops and of weeds, but that might be considered a benefit. Also, the one that you just talked about, there are places that are cold which will be happy to be warmer. There are places that have a moderate climate that will be unhappy about being warmer, and that's that balancing out of pluses and minuses I was talking about before. But I don't think anybody will be happy about the inundation of all the coastal cities on the planet, except, I suppose, the people who live on the new coastlines, who will be delighted to have boat traffic.
Yeah. Is there any difference of opinion at all within the scientific community over this trend? That is, with increased carbon dioxide and other gases building up, that by sometime next century, say year 2075, year 2080, the overall temperature will have increased X number of degrees Fahrenheit.
Defer to Drs. Manabe and others on this, but if you look at the 1982 National Academy report, I forgot the exact title, but climatic effects of CO2, a reassessment, something like that, they talk about a few dissenting scientific papers, and that is a few scientists who say the effect is not nearly as severe as has been widely advertised. And the Academy's report gives a very succinct explanation about why these studies are inadequate.
So in your judgment, the vast preponderance of the thinking of the community is in accordance with what you're saying?
Yes.
Okay. What's the best international arena within which to address some of these problems? I mean, we have to create a new forum, organization? Should we work within some existing organizations? Do we deal with this on an ad hoc basis? What guidance can you give us, at least in your thinking, as to how to get other countries to A, think about this, including this country, and B, how to work on some cooperative, constructive basis?
Well, it seems to me that the situation has to be arranged that everyone benefits. And a developing country that is being asked to forego readily available supplies of fossil fuels has to be given something of value in exchange. And if we develop fusion power plants that are effective, for example, then it seems to me that has to be
But I wonder if you've given any thought as to process. I mean, in addition to the information and substance.
I think...
Carl, before you go into that, I'm going to have to break and get over to vote, and so I want to express my appreciation to you for being here today on behalf of all of us and those who aren't here. Okay. Just finish.
I've got to leave too. I mean.
Okay, well, I didn't have a good answer anyway. So.
Well, you have about 15 minutes to think about it.
We'll recess the hearing. Thank you very much for coming. Did you want Carl to stay to ask more questions?
Oh, well, I have more questions, and we can, if he's busy, I can put him direct it. I'll write questions to you. Okay, thank you.
The hearing will come back to order. Undoubtedly, it's going to be disrupted again. We, overnight, discovered 41 amendments to the continuing resolution, which the Senate has once again risen to the occasion. Our next group of experts will constitute a panel. It will consist of Dr. Ralph J. Cicerone, the Director of the Atmospheric Chemistry and Aeronomy Division of the National Center for Atmospheric Research. Ralph, come on up and tell us the last time you remember having hay fever. Dr. Syukuro Manabe, Geophysical Fluid Dynamics Laboratory, the National Oceanic and Atmospheric Administration, NOAA. Dr. Gordon J. MacDonald, Vice President and Chief Scientist of the Mitre Corporation. I need to ask you, Gordon, are you the Gordon MacDonald that's so famous around this place?
Which one? I also have a son who's...
Oh, that must be your son. And then there is Dr. Dean Abrahamson, who first pricked my conscience on the environment 20 years ago now, as the first of a small group of, quote, environmentalists, end quote, which we didn't know much about in the public policy arena in Minnesota, of all places, in the mid-'60s, who's been a professor at the Humphrey Institute in Minneapolis for 8 years, and co-chairs the All-University Committee on Environmental Quality, teaches energy policy, director of the Institute's Global Environmental Policy Project, is an advisor to the Royal Institute of Technology in Stockholm, which is important for Minnesotans to do. And we welcome all four of you and your statements, which will be made part of the record, and we will proceed with Dr. Ralph Cicerone.
Thank you, Mr. Chairman, for the invitation to be able to speak with you on this issue. With your permission, I would like to append, I think, 4 technical appendices to the material that I'm submitting to you today.
Without objection, that is appropriate. And you might pull your microphone in the general direction of your...
Also, with your permission, what I'd like to do is to paraphrase and jump in and out of my written testimony to try to go as quickly as I can.
Please do.
My main point today will be to try to summarize for you information that we have on other gases besides carbon dioxide, whose effects are additive from the point of view of the energy balance of the Earth, that is, additive in the direction of warming. I'll describe some of the properties of those substances, what we know about them, and a few things we don't know. And I'll try in my own words to give you an idea of the dimensions of the global issue that we're looking at, namely that the forcing of this radiation on the Earth's energy system is unprecedented in recorded or measured history, and also in what we can deduce between interglacial warmings. Dr. Sagan has already spoken about the atmospheric window, which is a peculiar property of the gases in the air today, that there is a region of wavelengths between about 7 and 13 micrometers wavelength where the air is really relatively transparent. This window has been known about theoretically based on the properties of the chemicals in the air, what we can measure in the laboratory. But its existence is also proven from satellite measurements looking down on the Earth and other ways of observing the Earth's atmosphere. This is not a hypothetical phenomenon. And its special importance is that over 25% of the radiation that escapes to space and a much higher fraction from the top of the atmosphere leaves through this window region. So that if one were trying to change the Earth's climate intentionally, if you take that point of view, one would have to look for leverage of that sort, or the type that Dr. Sagan mentioned, changing the reflective properties of the Earth's surface by changing land use patterns, for example, from forests to deserts. Another strong lever we have over the Earth's climate is this atmospheric window region. Well, how would one go about trying to change the energy balance of the Earth? In my testimony, I point out that all the energy usage on an annual basis by humans is less than 1/10,000th of the rate at which energy reaches us from the sun. Just to give you an idea of the magnitude, we couldn't go out and simply burn things and try to make the Earth warmer. The numbers don't add up. The window region of wavelengths gives us this leverage. Well, what are the properties of chemicals that can work toward that task? We need chemicals, if one were to try to do this now, that absorb radiation in that special wavelength region rather strongly, and which don't overlap with wavelengths that are already rather absorbed. As Dr. Sagan gave us this graphic description of air looking black at 15 micrometers, you wouldn't want to waste your absorbers on wavelength regions that were already absorbed. You'd look for chemicals that absorb in between in that window region. Secondly, you'd look for chemicals that can last once they're out in the atmosphere. Why do you want the chemicals to last? So that you can only use a pinch of them to get some leverage, that you can build up reasonable concentrations in the air with relatively small amounts of chemicals, and so that global coverage would be attained, so that, for example, a chemical released in Stockholm can survive a matter of a year or two to make its way to the southern hemisphere to create a more or less global effect. Well, that's what we're dealing with many of these other gaseous chemicals, and the ones I would list briefly today would be several chlorofluorocarbons and chlorocarbon gases that are synthetic, nitrous oxide, which is laughing gas, a rather natural chemical really, methane, which also has some of its presence due to natural activities, and ozone in the lower atmosphere. Of those, the chlorofluorocarbons stand out in several ways. First of all, they are the longest lived. Some of them are now proven to be able to exist in the air once they're airborne for over 100 years. Others in tens of years, a couple of them in multi-hundreds of years. Their sources are the easiest to understand because they're synthetic. We know where they're coming from. We know why they were invented, where they're produced, in what quantities, how they're used, how the usage patterns are changing, that the United States initially was responsible for more than half of the production, usage, and applications of these chemicals, but that fraction is now well less than half due to the adoption of these very useful chemicals worldwide for a number of applications, such as refrigeration, as well as aerosol propellants and solvent usages, specialty applications, foam blowing, and so forth. We know how fast those chemicals are building up in the atmosphere. The rates of increase have slowed down to of order 5% per year increases, so that on a percentage basis, these chemicals are building up far faster than any of the other ones that we'll mention, including carbon dioxide. Their concentrations are the lowest of all the ones we'll speak of, but their infrared absorbances are very high indeed. In the case of nitrous oxide, we're really unsure as to why it's increasing, but we know that it is increasing in concentration globally at a rate which sounds rather small, only about 0.25% per year. And if you think in terms of inflation, economic inflation, that's a small number. But what's interesting about nitrous oxide is that that very small rate of increase tells us that the whole global nitrogen cycle, this nutrient cycling globally, may be rather strongly out of balance. We can prove that even at that small rate of increase, it tells us that whatever the sources of nitrous oxide are, they are about 25% higher now than the unperturbed natural sources. We think that the two candidates for the nitrous oxide increase are combustion of nitrogen-rich fuels and the microbiological transformations of nitrogen fertilizer applied in agricultural settings, both nitrification and denitrification of nitrogen fertilizers. Atmospheric methane is, I think, more dramatic and more vexing right now than the others because its sources are not very well quantified. But we know that atmospheric methane molecules last about 10 years each in the air. That tells us immediately from measured amounts the total of the methane sources, even if we don't understand which individual methane sources are most responsible for the present measured rate of increase of a little over 1% per year globally. The key candidates that we believe are forcing this methane increase are increased rice agriculture, multiple cropping, which of course keeps the soil underwater perhaps 8 months a year instead of 4, increased population of ruminant animals, increased rates of biomass burning, largely tropical forest clearing for agriculture, increased coal mining, mineral exploration, natural gas transmission and mining. All of these activities result in more methane in the atmosphere. But we also have another logical possibility, which is a live one right now, that something is changing in the chemistry of the global atmosphere, which is decreasing the atmosphere's ability to assimilate these otherwise normal entries of methane into the atmosphere every year. It's the OH gaseous radical. It's like a fragment of a water molecule in the air that we believe is responsible for destroying methane naturally in the air. And there are indirect indications now that atmospheric OH is decreasing under the influence of human activities perturbing this very complicated atmospheric chemistry that we've just begun to understand. I'd like also to mention atmospheric ozone, because the complications of atmospheric chemistry really confront us here. We now know that atmospheric methane, or ozone, is decreasing in the upper stratosphere. It appears to be increasing in the lower stratosphere, that's above the weather systems, and it also appears to be increasing where it's a most potent greenhouse gas in the troposphere, the region of atmosphere closest to us. We believe that the increase is due to anthropogenic nitrogen oxides and hydrocarbon gases, but the quantitative information is quite lacking here, so that prediction of future trends is very difficult. I've covered a lot of this material in the technical appendices which I've contributed. I'd like to close just trying to describe the dimensions of these effects a little more clearly. I think we've been focused too much on a doubling of carbon dioxide as the only thing to be concerned about. There will be climate effects which will probably be distinguishable by scientists and felt by humans before there's a doubling of carbon dioxide, and that's certainly before the middle of the next century. The time lags, of course, have to do with oceanic heat uptake and several other phenomena that have already been discussed. But the added radiative forcing of these other trace gases will bring on each of these effects earlier than if we were simply to wait for carbon dioxide to increase. There is no recorded information or even any theory that says that the sun has changed enough in the last 100,000 years in any sustained way to alter the energy balance as much on the income side as these trace gases are already doing on the output side. I think that should give us pause for concern that natural variability of the sun is smaller than the forcing contributed by humans now. And I've already mentioned that the total effect of carbon dioxide and the trace gases on decreasing the outgoing energy to space.
Go over and vote. And,
that's the end of my statement.
Okay. Thank you very much. My apologies to the other witnesses.
For giving me an opportunity to appear here to testify on the climate warming issue. I work for National Oceanic and Atmospheric Administration, so Department of Commerce myself. One of the most powerful tools for the study of climate problem is mathematical climate models. And this mathematical climate model consists of a system of equations which represent the behavior of atmosphere and oceans. Now, atmosphere component of such a model is very similar to the one which is used for weather forecasting, daily weather forecasting, U.S. National Weather Service, and many other National Weather Service of many other nations. And so what you hear about as a computer guidance is the one you get that thing out of this atmospheric computer models. Now, we have known this kind of model, which uses present supercomputer, can reproduce the major, mimic the behavior of the atmospheric circulation, and can simulate the geographical and seasonal variation of climate very well. Also, these models seem to be able to simulate past climate, such as last glacial maximum. So encouraged by this success, we have used this model for wide variety of climate problems, including the problem of greenhouse gases and climate warming connection problem. Now, they recently already discussed quite a few previous speakers. The international conference was organized jointly by United Nations Educational Program and World Meteorological Organization and International Council of Scientific Unions, assembling these experts, discuss the climatic change due to greenhouse increase and its associated impact. I was one of the participants of this meeting. The executive summary of conference report concludes that if present trend continue, the combined concentration of carbon dioxide and other trace gases in the atmosphere would be radiatively equivalent to doubling of carbon dioxide from pre-industrial value, possibly as early as year 2030. What this means that CO2 equivalent of greenhouse gases will double from pre-industrial value somewhere maybe 40, 50 years from now. This is discussed earlier by Dr. Cicerone, and based upon the result from most advanced climate model, the report states that the climate warming due to the doubling of these greenhouse equivalent, CO2 equivalent gases will be something like 3 to 2.5 to 8 degrees, concurring earlier statement made by U.S. National Academy of Science. The report cautioned, however, that the value outside this range cannot be excluded between the present imperfection of the models. And the warming will be further delayed by several decades by the thermal inertia of oceans. Nevertheless, it is highly likely from these estimates that the warming of something like 2 to 8 degrees Fahrenheit will be reached in the second half of next centuries. And the report noted that a climate change of that kind would have far-reaching impact on human life and planet ecosystem. At the Geophysical Fluid Dynamics of NOAA, I have been working on this problem past 25 years. You wonder how come you spend so long on this problem? It's very painstaking, long-term process to improve these mathematical models. And anyway, one of the results from obtained from this climate model, obtained from at our laboratory and other institutions, this climate change is not very uniform. It's far from uniform geographically. It has a particularly large warming in high latitude during winter, making a severe winter less severe in Canada and Soviet Union in winter. The other consequence may be, which model indicate, is a reduction of sea ice coverage over Arctic Ocean and circumtarctic oceans. This is another consequences which model indicate. In the tropics, warming would be smaller, but you know, well, tropics is already hot enough, so I don't know whether that implies any consolation to us. The other indication of climate model is that the atmosphere in the warm and CO2-rich world, air can contain much more moisture in there, so that warm, moisture-rich air can penetrate into high latitude and then drop precipitate there. So that this increase very substantially the runoff, annual mean river runoff over northern Canada and northern Siberia. And this probably have very interesting implications. Other result of climate model is reduction of soil moisture over extensive regions of mid-continental region over North America and Eurasian continent. For example, over Great Plains, this kind of soil moisture reduction is characterized by dry soil, reduced cloud cover and hot air temperature, which resemble the Dust Bowl period, situation in Dust Bowl period in 1930s, when northern hemisphere average mean temperature was significantly above normal values. And that pictures, this reddish, brownish red area indicates the area where soil moisture reduces more than 20% here. And you can see the present, still limitation of present model. You shouldn't take literally every small wiggles in these things, because computational resolution model is very coarse. But what does seem to indicate is that major area of mid-continental area over USA and Western Europe and large area over the Eurasian continent, soil moisture reduces. Why? One of the important mechanisms is when climate gets warmer. As you already know, in spring in the Midwest, it's flooded with rivers, the flow. It's very wet in spring. And then after snow melt season ends, the sunshine increases, snow doesn't reflect sunshine anymore, so it's much more radiation energy, more evaporation. So soil dries from spring towards summer. Now, in the warm climate, when snow melt season comes earlier, what does it happen? Then earlier ending, termination of snow melt season, make it so that spring to summer drying of soil moisture commence earlier, making summer drier. The other mechanism is that it's involved a little bit to explain it, but
You need to use the microphone if you want to be on C-SPAN.
The other effect is that, sorry about that. The other effect is that also spring rainy period end earlier, which again makes this summer drying begins earlier, so that makes summer soil drier. So these are rather robust phenomena which may not depend upon the detail of the kind of warming. Of course, there is major uncertainty remains, as pointed out by earlier speakers, in the estimate of climate change due to the increase of greenhouse effect. For example, it is difficult to determine with confidence the delay in climatic response due to the summer inertia of ocean. How much climate will delay by oceanic summer inertia? And this is because development of ocean model, we don't use ocean model for ocean weather predictions. So meteorologists have the advantage. The development of ocean model is still early stage of development. Another thing, basic reason why we have to say 2.5 to 8 degrees Fahrenheit seems to be very wide range, depending upon which one you believe. Its assessment of this effect is quite different. Is because of our ignorance, our inability to model cloud cover, interaction between cloud cover and radiation. And you can see how difficult it is to put the cloud cover in mathematical model, such a nebulous problem here. And so these cloud cover and ocean are the topics which is chosen by World Climate Research Program as two of most important research topics for the studying next decade or so.
You get me very interested when I see the possibility that in the Red River of the North and the Lake Agassiz Basin, the 35-mile radius in the wheat heart of North Dakota and Minnesota, that we might not have floods. But then it bothers me that we might have more than 5 tons per acre of soil blowing from one state to the other because it gets drier and drier, and we lose the wheat basket both in our country, and we lose it in Central Europe, and we lose it in the Soviet Union.
Yeah. Now, one thing, however, you have to remember is that it gets wetter in winter.
Wetter in winter?
Winter. In our model. Model indicates it's getting wetter in winter. So this is something to consider in connection with water management in middle latitude. Now, after listening to my presentation, you may wonder whether climate may have already changed due to the past increase in greenhouse gases. This is a natural question you would ask. The BRAC conference report noted that global mean temperature has increased by about 3 to 7 tenths of degrees centigrade, which is about 0.5 to 1.3 degrees Fahrenheit during last 100 years. Now, this is consistent, not inconsistent with the expected warming from the result of model calculations. But BRAC conference could not prove that this is due to greenhouse warming because we don't know, as pointed out by earlier speaker, exactly how much was solar constant was really constant, or how the stratospheric loading of aerosol have changed during last 100 years. And these information are so inaccurate that we can't prove scientific rigorous manner that perfect past warming is attributable to greenhouse warming yet. Now, to detect future change of climate due to greenhouse gases, it is imperative that we monitor the basic variable describing climate, as well as factors that can cause its change. These measurements will require sustained and serious commitment on the part of this country. In addition, real progress will require increased level of international scientific cooperation in monitoring and modeling of climate. Thank you.
Thank you very much. Gordon MacDonald's father. Gordon, your statement will be made part of the record.
Thank you, Mr. Chairman. My assignment this morning is to discuss the biological and oceanic consequences of increasing carbon dioxide. In looking at this problem, there are considerations as to whether or not the oceans can ameliorate possible climate change and how the plant systems of the world will react as the carbon dioxide content increases and climate adjusts in the manner described by the previous speakers. There are two kinds of effects that one is concerned with. First, there's the direct effect of carbon dioxide increase. As the carbon dioxide concentration in the atmosphere increases, some fraction of it will dissolve in the ocean. Similarly, as carbon dioxide increases, a wide variety of plants, not all, but many, increase their productivity. In fact, of the total amount of carbon dioxide being released into the atmosphere, only about 45% remains in the atmosphere. The other 55% is sequestered either in the oceans or the biosphere. We're not certain. This is one of the large uncertainties that remains in this problem. What we do know is that that fraction has remained more or less constant since 1958, when the first detailed observations of the carbon dioxide concentration of the atmosphere were made. There is a much more difficult question of the indirect effects. That is, as climate changes, the atmosphere warms, some of that warmth will be transmitted to the ocean and warm the oceans. In fact, the oceans can act as a moderating influence on the warming by absorbing some of the heat that otherwise would go in to further warming the oceans. But as the oceans warm, carbon dioxide is driven out of the oceans, and you have the possibility of what's commonly called a positive feedback, that as you increase the temperature, you drive more carbon dioxide out of the oceans, increasing the temperature to a greater degree, and so forth. But the ocean circulation is a very complex matter, and as Dr. Manabe pointed out, modeling of the oceans is nowhere nearly as sophisticated as that of the atmosphere. despite, I might say, the very heroic efforts of Dr. Manabe and his colleagues in trying to bring the oceans and atmosphere in tune, at least as far as the computer models are concerned. Just to give you a flavor for this kind of complexity, the ocean circulation is largely controlled by the sinking of cold water in the Norwegian Sea, the Labrador Sea, and to some extent the Weddell Sea in Antarctica. This cold water sinks, penetrates to some depth within the ocean, and follows a meandering path on the average to rise several hundred years later. As it disappears to depth, it carries with it some of the heat and some of the carbon dioxide. A real problem, and one which is not clearly understood, is how that process is going to be disrupted or changed as climate conditions alter the world over. Similarly, the response of biological communities to changing climate, the indirect effect of increasing CO2, is highly complex. The best we can do at present is to look at historical data, and again, to give you a flavor, and I select the Red River Valley for obvious reasons of the membership of this committee. Spring wheat is a major crop. One can make an estimate that says that a 1 degree centigrade rise in temperature leads to an increase in the growing season of about 10 days. Coupled with this warming, as Dr. Manabe illustrated, there will be drier conditions. So the direct effect of lengthening the growing season can be anticipated, and you can check it by looking at the historical records, to increase wheat productivity. On the other hand, there will be a higher frequency of very warm days in June and July when the spring wheat heads, and during these infrequent times, the hot spells will reduce productivity. And in fact, the best estimate today would be that if you had a 1 degree rise in temperature in the Red River Valley, 10% decrease in precipitation during the summertime, that the productivity of the wheat would decrease approximately 10% in yield. Now, this is just one example. There will be different responses in different areas, and as I say, this example is drawn purely from historical data and would not allow for larger range excursions. In looking at the long-term effects of climate on agricultural productivity, on water resources, those aspects of our society that form the base for our economy, we have to ask 3 related questions. With the warming, will there be a greater effect in winter or in summer? What will be the effect day versus night? And what will be the impact on the extreme variations, the periods of drought, the periods of early frost, the storminess, the frequency of hurricanes? To the first question, Dr. Manabe and his colleagues have indicated that yes, the seasons will differ. Winter will tend to be warmer. The day-night issue is very much a mystery, and to my knowledge, has not yet been adequately dealt with. The question of extremes in climate remains almost a total unknown. The best that can be done is to argue by analog. This is an imperfect argument, but it says that if you have complex systems that undergo changes in which the equilibrium state is changed. And here we're changing the state to which the atmosphere would like to arrive at continually as gases are added to it, that the fluctuations, the highs and the lows, will become more extreme, and that this greater noisiness of the weather can be anticipated to come perhaps long before you see the large shifts in average conditions. Now, given these uncertainties, what are some steps that might be taken? And I've selected 4 items that indicate the kinds of issues on which governmental action could exercise some leverage on the longer-term problem. Fuel efficiency standards for automobiles and light-duty trucks, a subject that has recently received some attention. As you loosen the requirements on fuel efficiency, you will use more energy. You will also produce greater amounts of carbon monoxide and oxides of nitrogen in total, even though the standards are mandated, and thus increase the effect of other trace gases referred to by Dr. Cicerone. A second area in which Environment and Public Works Committee has direct responsibility concerns the Clean Air Act amendments and various proposals to deal with acid rain. The chemistry of the atmosphere is involved in problems of climate change. It's also involved in problems of acid rain, and I have prepared for the committee a paper detailing these links. Now, just as an illustration, one of the climate-changing gases is ozone. Ozone is a very strong oxidant and reacts with sulfur dioxide in the atmosphere to convert it to sulfuric acid, part of the acid rain phenomena. Reducing sulfur dioxide by itself as an isolated action might have the impact of increasing oxidant levels. Those increased oxidant levels could worsen the climate change problem, and oxidants themselves may be responsible for damage that is generally attributed to acid rain, but the damage to forests, the damage of that sort. I believe that in looking at the Clean Air Act and future amendments to it, and looking at acid rain proposals, the issues related to climate change have to be integrated and considered concurrently. A third area is environmental impact statements. I have almost a nostalgic view of this bureaucratic monster that was created some 15 years ago. The environmental impact statements were in large part designed to alert decision makers as possible adverse effects that could take place through proposed governmental action. As a one-time avid reader of these statements, I do not recall the climate impacts as an element in the considerations. For example, in considering the relaxation of the fuel efficiency standards for automobiles, the climatic impacts were nowhere considered. And finally, I believe that research, a topic addressed by Dr. Sagan, is clearly an area which needs far more attention, and I was much taken by Senator Gore's proposal to focus attention on this through an international carbon dioxide year. I'd perhaps broaden it to perhaps the year of the atmosphere, but to focus attention on those elements of research that will reduce uncertainties as to what will happen in the future. The uncertainties will always be there. We will never be able to predict with perfect confidence. On the other hand, we can reduce those uncertainties that exist at present, such as what is the role of the biosphere, what are the roles of the oceans in damping or perhaps accelerating climate change. In closing, I'd like to compliment the chairman and the committee for holding these hearings. I think this issue is of comparable importance to any issue in the long term, with the obvious exception of nuclear war. I think we need to keep the issue, the awareness of the issue at a high level, and discussions of this sort certainly contribute to that goal. Thank you, Mr. Chairman.
Thank you very much. Dean Abrahamson, welcome.
Thank you. Thank you, Mr. Chairman. Senator Gore. I'd like just to have permission to introduce the VLOC conference statement into the record if nobody else is going to do it, and also
without objection, it'll so ordered.
Extend the responses to questions a little bit. I have a sense we're not going to have time to explore all the details of well, I was asked last night why I was bothering to spend time on this issue, and it was my response that I think this is the major environmental and economic issue that we're confronting now, again, short of the nuclear war question. What we decide to do about limiting temperature increases is going to have a major effect on virtually every aspect of our society, if not in our lifetime, certainly in that of our children. My written remarks and also what I say this morning is can cast around a scenario of a warming of 5 degrees Celsius. That's 9 degrees Fahrenheit. And I chose that number because, well, for a number of reasons. One, I think that a warming of that extent within the next few decades is entirely plausible. Secondly, it will have major impacts. Third, we know something about the climate response to forcing of that kind. And lastly, if we're vigorous in taking policy initiatives, we may be able to limit warming to 5 degrees. I don't think that anything much lower than that is realistic, unless things turn out, and comment on that later, unless things turn out in the most optimistic way throughout both the science and the policy responses of things. But what would be the sorts of impacts we would see with a 5-degree warming or a warming of that kind? I'm not going to go through all the gory details, just rather read a summary list of issues that are raised by climate change of that magnitude. Threatening endangered species, habitat preservation, coastal zone protection, all legislation affecting inland rivers and lakes, dams, water diversion, and groundwater protection, hence concern over hazardous wastes, wind-driven soil erosion and desertification, and hence Western federal land management and reclamation projects. On the economic side, the list would have to include grain, vegetable, and animal agriculture, fiber production, all activities dependent upon in-stream river flows, for example, electricity and synfuels production, urban water supplies, barge transportation, and agricultural irrigation. Many forms of recreation, coastal development, fisheries, settlement patterns, particularly coastal, and forest-related industries. For example, just to pick an example, what would changes of the kind being discussed today imply for the carrying capacity of the Los Angeles Basin? You can't answer questions like that because they haven't yet been asked. And virtually no effort has gone into impact analysis certainly nothing comparable with the magnitude of the changes that the excellent science that's been done in the last couple of decades seems to justify. I think we could avoid a warming of 5 degrees. If you look at the energy policy alternatives that we now have, I think that a vigorous policy to increase end-use efficiencies, to avoid coal at all costs, in fact, reduce the absolute levels of coal consumption, use natural gas as a transition fuel, and a number of other things. That is, those policies to achieve an energy supply and end-use structure that would result in limiting to on the order of 5 degrees exist. And I think their implementation is realistic. Next point is I can't take much credence with talk about adaptation. The nature of the impacts and societal response to the impacts will depend not only on the amount the temperature changes, but the rate at which it does change. And what we're talking about here is a temperature change greater than ever before experienced during civilized times and a long time before that, taking place over a time that is short compared with lifetimes of either trees or people. And in terms of impacts and response, the rate of change is at least as important as the total magnitude of the change. We're talking about changes happening in short times with respect to social and economic timescales. Question was asked earlier this morning by one of the members. When do we have to do something? Well, when we have to do something is that question has to be answered by to what level do you want to limit the damage? I will argue that if you want to limit the temperature increase to something like 5 degrees, that if you begin now and are vigorous about it, you may be able to do that. Only under the most optimistic set of circumstances can a policy of wait and see still result in a temperature increase of less than 5 degrees. That is, you have to take the lower limit of the temperature sensitivity to a doubling, you have to take a lower limit of the effects of the other greenhouse gases, and you have to take a lower limit of the inputs due to the things mentioned by Dr. MacDonald, namely increased respiration as a result of warming, outgassing of CO2 from the oceans as a result of warming. And once you add all that up and look at the things that can be directly affected, like chlorofluorocarbons, like fossil fuel consumption, like deforestation, if you're vigorous about it, you can probably keep it to below 5. But on the adaptation side, the lead times for the systems, the hydrological systems, for example, those suggested by Dr. Manabe, are long compared with the rate of change of temperature. And to implement those, one needs rather specific regional information, and it has to be available with reasonably high certainty in order to support anything like anticipatory planning. And by adaptation, I think people ordinarily mean planning for the change so that it will be relatively less disruptive. I think that is almost, well, it's a Panglossian notion to think about anticipatory adaptation to this issue. On the other hand, I think we know enough now to justify, in fact, we know enough so that to implement those measures which will delay and limit the temperature increase, the climate change, and further, virtually every one of the measures, not only suggested this morning, but that are in the literature, are justified on other grounds as well. I mean, I think that things like improving energy efficiency are justified solely on the basis of the carbon dioxide problem. But there's a bunch of other reasons, a bunch of other issues that they will help at the same time. Some specific policy recommendations. One, Dr. MacDonald mentioned incorporating it into the EIS process. Well, I like that too, and there are now measures underway to encourage the Council on Environmental Quality to do the necessary rulemaking to require that climate change implications be included in the EIS process. That is not the case at present. Hopefully the administration will respond. Something like increasing auto efficiencies. It's already been mentioned, but I want to elaborate a little bit. Increasing auto efficiency will have multiple benefits. First of all, as already been mentioned, it will directly decrease the emissions of greenhouse gases, carbon monoxide and carbon dioxide. But perhaps more importantly, it'll reduce oil consumption, it'll reduce pressures on oil prices, it will tend to stabilize oil prices, and thereby extend the oil resource. But perhaps most importantly, it will go a long way to discourage the shift to coal and to solid hydrocarbon-based synfuels. I think, well, if we're part of the limiting the temperature increase to 5 degrees requires a reduction in coal use. It doesn't require a slackening of the growth rate, it requires an absolute reduction in coal use. Some rather elegant work has been done over the last years, part of it at MIT by Dr. Rose and his colleagues, part of it at Princeton by Bob Williams and his colleagues, and they've shown that if you take a scenario, for example, the energy end-use efficiency opportunities that are now present, and what that means in terms of oil and natural gas, consider coal as the swing fuel to limit CO2, and if you're going to limit CO2 to 1.7 times pre-industrial levels, which correlates roughly with our 5-degree scenario, then coal use would decrease in absolute terms about 20% before the year 2020 and continue the reduction at an exponential rate at about 0.6% per year thereafter. Part of that should be to encourage natural gas as a transition fuel. And of course, in those measures to increase end-use efficiencies of energy generally. Second point on some recommendations is again to reinforce Dr. MacDonald in stressing the importance of the biota. Deforestation is may well be a major source of CO2 in its own right. The evidence is not unequivocal on that point. Deforestation is also associated with the production of a number of the other greenhouse gases. That's already been mentioned. But the whole biotic response is known with much less certainty than the fossil fuel response. And we desperately need to know there are large pools of carbon that may be oxidized fairly rapidly with increasing temperature. The respiration rate increases about 3-fold for every 10 degrees Celsius change, as Q10 of about 3. And so for every degree increase, you're going to get 20-30% increase in respiration rate, which means the oxidation of these pools of carbon present in the soils, et cetera, and peaty soils, forest soils, et cetera. We don't know much about that. And lastly, I think we need some pretty hard-nosed impact analysis, not only so that we know what we're facing and can justify the policy measures to limit it, but also to get some feeling of what sort of societal transitions there are going to have to be, so we know a little bit more about where we're going. What are the effects on these systems that I mentioned before? And should mention that the costs of the biotic work, the costs of the impact work, the policy analysis it costs orders of magnitude less than the costs associated with the basic science, the satellite work, the model work, and so forth. Yet the policy response and the societal response is wrapped up in those things much more than improving the resolution of the models per se. Thank you.
Thank you all. I was I could tell Dean was concluding, I picked up the January issue of Discover and the article, Are We Close to the Road's End? And there's a distinguished-looking gentleman lighting his pipe in there, which I no longer do. I haven't done that for 11 and a half months now. I was obviously attracted to the picture, and under it says, Kumanoff thinks those who link global warming to CO2 buildup are blowing smoke. I think Kumanoff has some position of responsibility in this administration. That seems to be his view. How do the rest of you view the preparation that is being made for us currently at the government, the national government level, for these problems? Are we preparing for them? Do we believe that people on this panel are blowing smoke? What is the perception of what our government is doing to contribute to an international solution? Anybody want to respond to that? Gordon?
Mr. Chairman, I can start. Mr. Komanoff does head the carbon dioxide research program within the Department of Energy, and I'm afraid his comment does reflect a prevailing attitude within government at this time. There is first-class research conducted at NOAA and through the National Science Foundation support of institutions such as the National Center on Atmospheric Research. The work has largely centered on modeling, and I believe that this has been proper in the early stages. But as we get to know more about the complexities of the issue, there's going to, in my view, have to be a greater emphasis on, let's say, understanding the detailed chemistry within the atmosphere. This means making many measurements, using satellite observations, having a much more of an integrated program than we have today. Research on the ecological aspects is fragmentary. Very little is put together in any sort of coherent way, and yet I feel it's critically important to make judgments as to how our life-sustaining agricultural and other plant systems will respond to climatic changes and changes in atmospheric chemistry. And finally, I strongly support Dean Abrahamson's comments with respect to the need for policy research. Very little is underway. Other than that, I think that he himself has led. And I believe that these separate elements do not go toward making a total program. It's highly fragmented. On the international arena, the World Meteorological Organization and the UN Environmental Program have initiated steps, but I think only in a preliminary way. And a far broader and greater effort, again, perhaps along the lines suggested by Senator Gore, is something that I think would be, that is very much needed.
Okay. Dr. Manabe, I want to return to the major point of your testimony, that is people to really understand the scenario of soil moisture changes that you suggest they need to be able to somehow picture it in their mind. And you put up a mind picture and we had to take you back to the microphone or something. So is there a region in our country or in the world that today has the temperature and moisture characteristics that your model indicates will prevail in the center of North America? For example, the Red River Valley and Minnesota early in the next century. Is there some place where today we can get a feel for what you model as tomorrow? And And will these so-called Dust Bowl conditions prevail in other areas of the world, like in Europe and the Soviet Union, for example? I'm now very interested in that as chairman of the Intelligence Committee, and where there are other bread baskets like we have in the upper Midwest.
The Dust Bowl is a very good qualitative analogy to the kind of condition we are getting in the mathematical model. If you are asking me, is there any other places which is similar dryness, it is very difficult to find analogous thing because it's getting wetter in winter and get drier in summer. So, I can't say it's similar to desert, obviously, because winter, it's wetter. And so one way to calibrate this is if you look at, even now, you have a large year-to-year fluctuation in soil dryness for probably nothing to do with greenhouse gas warming, just a natural fluctuation of soil wetness from year to year. And the magnitude of reduced soil wetness is about comparable with the magnitude of fluctuations from year to year. So there is a very interesting consideration to make. That is that if we do some water management, which take care of natural fluctuation now, we're going a long way towards preparing for such a sort of thing. That may be one way to describe this dryness problem. Does that answer?
I am going to have to depart. I understand it is not without the tradition of this committee to permit senators to continue meetings, even though they aren't on the committee. We wish you were on the committee, Al, and because I know of your interest. We have a large number of questions which will need, as Dean indicated, will require response in order to make a complete record. We have let the testimony go much longer than the usual, either 5 or 10 minutes that we restricted it to, but by the same token, I know all of you felt limited in what you were able to present here today, so we will submit questions to you. And I will now turn the hearing over to our colleague from Tennessee, and as long as he is willing and you are willing, you may continue this hearing, at the end of which I would appreciate your formally adjourning it.
Well, Mr. Chairman, I appreciate your courtesy all the more because it departs from the traditions of the committee, and I will not strain your courtesy or that of the committee by asking very many questions, just a couple of brief ones, however, mainly about political questions. As I understand your testimony, if we take the political choice of waiting to see more about what's going to happen, the consequence of that choice will be to limit our options for responding to the greenhouse effect. And by increasing the impact the world will likely experience from the greenhouse effect. Are you all in agreement with that statement?
I certainly am. I think the question of time scale is critical. In order to introduce a new energy, it takes at least 50 years, or to change our water resource management infrastructure, or any of the underlying structures of our society, takes a matter of several decades. Yet we're talking about possible changes in times of a few decades.
Yes.
And it's that mismatch of timescales that make this such a critical issue now.
Yes.
And indeed, if we wait too long, then the changes will be upon us, and reaction will be of the sort to limit damage rather than to manage for benefit.
Anyone disagree with the statement as made? Well, second to proposition. In order for our country or for other countries with different political systems to organize a reaction equal to the challenge, we need a greater degree of certainty that such a reaction is absolutely essential in order to avoid the dire consequences sketched out by scientists like those on this panel. At a very minimum, at a bare bones minimum, therefore, the meagerest responsible approach would be to greatly accelerate the scientific efforts to diminish the remaining areas of uncertainty and enable policymakers to present their respective publics with evidence to which no one could respond as Mr. Kumanoff has responded by saying, "Convince me, I'm not sure this is real." 95% or 99% of the scientific community that's looked at the evidence agrees with the point of view expressed by this panel and by Dr. Sagan earlier. But you also qualify your statements responsibly by saying that the extent of the impact is unknown, the time in which the impact will first be felt cannot be predicted with precision, because we don't know enough about the ocean system's interaction with increased CO2 or about the possible adjustments in the cloud system as temperatures increase, or about the contribution of trace gases, etc. The caveats and qualifications diminish political will out of all proportion to what the effect they should have. Because the central message you're giving us, stripped of the qualifications and caveats, is that we have a global environmental disaster of virtually unprecedented dimensions, building fairly quickly to a point where human civilization will almost certainly experience very large impacts in the next century. And that's what the scientific evidence points toward. Is that a fair summary of it?
Yes, Senator. There will always be uncertainty. We will never be able to predict the future with 100% confidence. It comes to mind that I was in this room testifying when Senator Muskie, in a moment of exasperation, say, "Give me a one-handed scientist."
Yeah.
Because on one hand and on the other hand, and you've heard that today. But we feel that there are uncertainties. The uncertainties will be reduced. But the problems and the consequences are so large that action over and above just further research, I believe, is warranted. And whether it is calling attention to the problem or taking measures along the lines that we've all talked about, energy efficiency, shift of fuels, limiting of the use of freons, banning the use of freons, a whole series of actions that, in my view, are not likely to cause great economic disruption, but at the same time provide us with the means and the time to more adequately deal with this longer-term issue.
Can I comment on that? As I see it, that I agree with Dr. MacDonald that we will always have some doubt about prediction by mathematical models. And as I experienced last 30 years I have been working on, progress has been steady but very slow. There are no quantum jump suddenly go up like that. So that I anticipate that progress in future also steady and slow. And so how to trust these models? One of the key is to commitment to long-term monitoring of the atmosphere and climate causing factors. And then you always use state-of-the-art climate model and compare what has happened. And then you gain confidences or lose confidences, but as keep comparing with the result of monitoring, at the same time improving the mathematical model continuously. And this is a passage I can see. And as we can demonstrate that mathematical model gradually has been explaining actual change in climate, our confidence will increase. Now, what this means that is, seem to me, rather than sudden commitment into something like that, but what we need is a very long-term, sustained commitment in the climate modeling improvement and climate monitoring. That's from the person who working on this, the research. That's the way I feel what we needed.
Yes, sir.
Senator Gore, I'm very encouraged by the fact that there's so much awareness and understanding of the principles, the physical, chemical, biological principles on behalf of people like you. And I see that consciousness growing around the world. I think one of the next steps that will make many people feel more urgency with this set of questions is that of the timing of the effects. The modeling work that people like Dr. Manabe do, I believe in the next several years we'll be saying much more about the timing of these effects. Up until now, it's been more common to deal with this canonical view of a doubling of CO2 whenever it occurs. Now there's much more attention being focused on the year at which certain effects might ensue or begin. And this target exercise of the type that Dean Abrahamson described, I think would be very useful for us to begin to get on with. As the timing of the effects becomes clearer, we can identify targets at which the change will be detectable and acceptable or unacceptable, and begin to identify what kinds of research are necessary to pin that down better and what kinds of adaptations. So I think the identification of some of those target levels, I'm a little worried about a 5-degree change as being unavoidable myself. That seems on the high side for us to immediately say it's acceptable or unavoidable, but without identifying those kind of target levels, we're not going to know, because we won't have done the biological adaptation studies, the looking into the shifting ecosystems, nor the policy impact statements. I guess I would like to stop my soliloquy or monologue with one reminder that the uncertainty we're dealing with exists on the high side as well. I don't think we know that we've bracketed these impacts as well as we say we have. They may be larger than we are saying.
Particularly if the ocean release of CO2 is on the high side, if that turns out as speculated.
An issue we have to deal with, which is not as difficult as the ones you have to deal with, are how to get scientists together from different disciplines to do this multidisciplinary work as opposed to interdisciplinary work. We're getting a lot of encouragement from places like the National Science Foundation and NASA, and I think a little less encouragement from places like the Department of Energy.
Well, yes, Dr. Abrahamson.
I'd like to comment a little bit too. First of all, I don't mean to imply that my 5-degree, I consider that acceptable. I think that's terrible. My point is that you don't even have to assume the upper end of all the present estimates in order to get 5 degrees, and 5 degrees is a very plausible number, and I agree, to which I think we're going to have to work hard to avoid. On your remarks specifically, Senator, 3 points. One is that I think that working to get an international consensus of the scientific and technical community is very important. Things like the VLOC meeting, I think do a lot to advance the cause. There have been suggestions that a lack of getting this consensus before the U.S. takes vigorous policy action may actually be detrimental. I don't know if this is true. I've heard it often, though, that, for example, when we moved rather quickly to ban the aerosol spray can use of chlorofluorocarbons, Europe lagged. And part of the reason for the lag was just a professional jealousy of the scientific community that they weren't involved, and that in some cases very personal considerations kind of interfered with that machinery. And I think that non-governmental efforts to achieve a broader understanding on the scientific basis can do a lot. Second point is that the U.S. plays a big part in this problem. First of all, in its creation, and secondly, in the means available to limit it. And I certainly hope that no one is suggesting that we have to get this kind of international consensus before we start to put our house in order. And the third thing is this has to do with this winners and losers. People very glibly say that some countries are winners, some countries are losers. The implication being, I think, that some countries will want to encourage it rather than discourage it. I think that with a little work, one could make a pretty convincing case that there are probably no winners. No winners for a number of reasons. That simply the stress associated with responding to the temperature change will sop up so much capital and put so much stress in the systems that it'll be disruptive, even if you can show that at the equilibrium of the change it might have been good for the place.
Yeah.
And secondly, it completely ignores the international political response.
Mm-hmm. Well, I was encouraged by some favorable comments about my suggestion for an international scientific year focused on this problem, and I intend to pursue that. With respect to your earlier comments and the interchange just now about whether or not 5% is inevitable and or acceptable, I think the distinction between acceptable and inevitable is important, and I take it that you don't disagree with that. But and the underlying point which leads you to speculate this, Dr. Abrahamson, is that we have in effect already lost the option of having zero effect. Pardon me?
Yes.
Because of past practices and the past introduction of massive amounts of CO2 into the atmosphere and other gases, we have already programmed in a greenhouse effect of some magnitude. Does anybody disagree with that? Nobody disagrees with that. And the question before us now really is twofold. Number one, how do we get better, more accurate, and reliable information about exactly what is likely to take place, when and where, because effects will be different depending upon location. And how do we get that information fairly quickly? Secondly, at what point do policymakers decide that the information is of sufficient reliability to warrant intelligent decisions that have the potential for mitigating the impact? The path of least resistance is, on both of those questions, to say, first of all, well, let's just wait and see. And secondly, if it turns out that it's too late to do anything, we'll just adapt to it. Well, the answers are, the reasons why those two strategies are not acceptable are, in turn, we can't just wait and see, because we've already programmed in some effect, and the longer we wait, the larger that effect will be. Secondly, if we have a clear understanding of how large the impact is likely to be, we would probably judge a policy of mere adaptation to be madness, even in light of the rather large changes necessary to mitigate the impact of the greenhouse effect. You said, Dr. MacDonald, that, well, I forget which witness said that deforestation may be equal to the extra introduction of CO2 as a cause of this phenomenon. Am I remembering accurately?
Yes, the biosphere, that is the forest of the world, store a great deal of carbon, as do the soils.
Yes.
And the deforestation currently underway, largely in tropical regions, could be increasing in a very significant way the overall CO2 burden. The fraction of the CO2 increase that is due to industrial gases and that due to deforestation
by the forest.
Yes, is not known.
It's not known. But your sense of it is that they may be of roughly equal
could be as
proportions?
large as the current increase. I think it's more likely that it is somewhat less.
Less. I know that no firm scientific data is really available on this particular question, but I'm interested from the other three panelists. What's your gut feeling of how you rank the importance of decreased absorption by the world's forests and increased introduction of CO2 and trace gases as causal factors here? Anybody want to venture a guess?
I think the weight of the evidence is on the increase side of the CO2 and trace gases. It's unfortunate that some of the tools that would be available to settle that question either are no longer valuable, such as in the case of carbon-14 studies, where the massive bomb testing in the atmosphere in the late 1950s and early 60s has rendered carbon-14 work on CO2 and methane less valuable than it would have been if the bomb testing had never occurred. Secondly, we simply don't know how to measure the world standing biomass to the accuracy required to know the difference between 99 and 100 units in a 5-year period. We don't have the satellite technology developed well enough yet to measure the changes in the biosphere fast enough. So I think the weight of the evidence then is on the increasing side of the gases.
Dr. Abrahamson.
Well, I called a number of my college's friends last week and asked them this question. And the response I got was an uncertain that the releases from the forest deforestation now certainly are not less than 1 gigaton per year and probably not more than 4. And the fossil fuel emissions are in the neighborhood of 5.
I see. Well, it's not negligible by anybody's calculations, and probably the reason I focus on that particular aspect of the issue is that as a politician looking at this problem in an overview, it is somewhat easier for me to imagine a global response to deforestation in the short term than it is to, although that would be quite difficult, than it is to imagine a global substitution of novel energy sources for fossil fuels in the short term. And if deforestation contributes anywhere from 20% to 45% of the problem, and it's feasible to begin addressing that in the short term, perhaps as a first-order political response, we could begin imagining a global strategy to combat deforestation. Again, as a couple of the witnesses indicated, there are other very good reasons for doing that, apart and aside from the greenhouse effect. But again, in order to convince the world publics that this problem deserves that kind of response and attention, we have to have better information, and we have to have it quickly. I personally am prepared to be convinced that the current state of information warrants an effort of that kind right now. But again, as a politician, I look at what is probably feasible, and I don't think that our government, much less others, are yet prepared to undertake such a massive effort on the basis of the evidence we now have. I think that we should begin now, but I don't think a consensus has yet been established in the political community that will match the consensus that has been impressively growing in the scientific community.
Senator Gore, I'd like to use this opportunity to once again emphasize the connection with acid rain. In Europe and in parts of this country, you have had associated with air pollution and generally with what's called acid rain, destruction of forest.
Yeah.
As those forests die, carbon is added to the atmosphere, and you have another clear illustration of how these systems are linked, and that you must consider the impact of one action on others. And I think that the acid rain problem and the climate change problem are totally linked through atmospheric chemistry.
4 years ago, I looked at that graph over there, which traces the parts per million CO2 in the atmosphere, and that particular version of the graph actually connects the peaks of the annual cycle. And I was struck, as a member of the Energy Committee and the other body, that if you overlay a graph of world consumption of fossil fuels on that particular graph, the dips in 69, 70, and 75, 76 correspond almost exactly to the dips in this graph. I asked witnesses about it at that time, and they speculated that although that was an interesting correlation, it might be produced by a statistical artifact of some sort or another. I'm wondering if there's been any statistical work since then that sheds light on that particular correlation. If the answer is no, just say no.
I don't have the details of those years in my head, but I do know that there's been enough of a CO2 record now to see the influences in energy usage upturns and energy usage downturns year by year, in one time at least. There's also been some dramatic connections with El Nino effects, where oceanic surface temperatures the effects of those and other circulation changes in the world's oceans can be seen on CO2 concentrations in the atmosphere.
Well, but presumably that something like El Nino would presumably be sensitive to the measuring points, and I mean, wouldn't that
it's not everywhere. That's
wouldn't
right.
that wash out on a global basis if you just had a shift in the patterns of the ocean warmth?
There's a large regional response, larger than global. That's right. There's also the beginnings of evidence that the annual cycles in the CO2 concentration that you referred to may be providing the evidence on the amount of biomass change, that is the respiration and drawdown of CO2 from the atmosphere, being linked to the amount of living photosynthesizing material.
Well, of course. I mean,
but the evidence in the record now is becoming clearer and clearer that it's not quite clear yet that we can tell the changes in the world's biomass, but there is evidence now that the amplitudes of the CO2 cycle are increasing a little bit.
Every once in a while, and I hesitate to raise this question, but I do, because every once in a while somebody raises the question of extraneous not extraneous factors, but of other factors not frequently mentioned, like termites. You dealt with that question? And if so, dispel that, if you would.
Well, the termite work has been done, a large part of it, in our laboratory in Boulder and in the field in Africa and South America by our group. Not me directly, but people working with me. It arose mostly in the connection of atmospheric methane, where it is absolutely clear that microbes living inside termite guts do produce prodigious amounts of methane.
I mean, and when you look at the magnitude involved, it really is very, very large.
And carbon dioxide. But if you're thinking about global change,
That's been constant.
that's the question.
Yeah.
And the ecologists are debating whether termite populations increase dramatically after an episode of forest clearing, or whether the termites are not quite so opportunistic, and I don't believe that question is settled.
So it could be, instead of just being a constant over the last several million years, it could be a kind of a flywheel effect that increases CO2 levels in the wake of deforestation episodes.
Well, all an increased population of termites would do would be to recycle things faster.
Right.
You get the same end products, but you might end up with the CO2 coming out of rotting and decaying material faster than would have happened in the absence of termites.
But given the magnitude of the gases involved, it would be statistically significant for any measuring scheme that we're...
Oh, yes. We don't commonly think of these things, but termites are on the lower end of the carbon cycle and cycle an enormous amount of carbon annually. But we also, to a first approximation, I think we have to regard them as part of nature that have been there for a long time.
Yeah. Well,
Did you have something else you wanted me to ask?
In terms of what can in fact be done.
What's that, CFCs?
Fluorocarbons, spray.
Yeah.
It was in Right Guard, and we banned it in this country in the mid-70s. That's what they were talking about.
Yeah.
It's one molecule of CFC is about 1,000 times the potency of one molecule of CO2 in greenhouse effect.
now chlorofluorocarbons, while small in total volume, are very powerful in their ability to absorb infrared rays, correct? And based upon your calculations, CFCs may account for approximately 1/3 of the greenhouse effect at the present time. Is that too large a figure?
I think that's, it's growing. I'm not sure it's 1/3 yet, but it's approaching that figure.
It's in that order of magnitude.
Right.
You mentioned earlier, one of the witnesses mentioned earlier, the lag response in Europe as compared to the United States action in banning CFCs. So if we wanted to come up with an effective measure now, we could push for bans elsewhere on CFCs in the short term, and that would have an effect that would not be negligible. Anybody disagree with that?
No, the care has to be taken to recognize the changing usage pattern. In the U.S., when the action was taken by, I think, 3 agencies together in the late 70s, there was leverage over what was judged to be less essential usages, like aerosol spray propellants. The changing usage now has emphasized more, you might say, more essential usages in many countries, although in many other countries of the world, the aerosol usage, which I think is correctly judged to be less essential, is still proliferating. So there is some leverage there, yes.
Okay, well, Chairman Durenberger indicated that he would have other questions in writing. I know that other members of the committee will as well, and I appreciate his courtesy in letting me finish this up and ask questions. And on behalf of him and the committee, if I may presume to do so, I would like very much to thank all of you for your testimony here today and your response to the questions, and we'll stand adjourned. Thank you.
See you.